Well, welcome to the second, the third podcast that we will be doing on the operational edge. I'm David Lee with User Centered Design Services. I'm partnered here with
Marsha Wisely, and I am with PlantWise Industrial Consulting.
So in our previous podcast, we talked about some of the problems that we've seen in industry around operator performance and operator errors leading to losses in industry. So we sort of took a very high level look at the different aspects of that. Today we thought we'd sort of hone in on one of the aspects and talk a little bit more about in depth. So today we're going to talk a little bit about training and the impact of technologies like simulation. I must profess that's not my area of expertise, so I'm going to lean heavily on Marsha for this. However, back in the 80s, I did use some of the early types of simulation software for process design, which I guess was what it was best for back then, running on big, heavy computers, very heavy in terms of programming. We did everything in Fortran and had to build all the models, although there was some physical models and things that we had available. But really, that's part of the exposure I've had to it. So I'm looking forward to finding out how things have improved and how we can use it more today to help us. So I guess thinking about that, using that original sort of application of running process simulation, I presume that's still a very heavy use of this type of technology today.
It is. So, process simulation, platforms like HYSYS are heavily adopted by the industry, in part because they do such a good job of getting involved in colleges. That was my experience. Was I used Aspen HYSYS and Aspen Plus when I was at Missouri S&T studying chemical engineering, doing my process design class. It has all the cost estimation and design tools and everything that you need. Perhaps a little bit smoother in terms of how it runs and smaller computers, but it's essentially the same, right? It's running those big engineering calculations. It's taking a look at your whole facility. The variables that it cares about are like, what are the sizes of your pieces of equipment and what's your feed and then it's going to tell you like what's your output going to be.
Mm-hmm.
Or you can say, what do I need my output to be? And it'll try to size your equipment, right? For training, that doesn't have quite the application, right? To your point, because it's just steady state controls. And from a training perspective, we care more about the dynamics of how that works. And so over time, instead of setting the variables to be these equipment sizes and your feed or your output of your facility, we decide that those are set because you've designed your facility and your equipment sizes don't typically change very much once you've actually built your stainless steel facility. And so those get set, and now all of your variables in your process simulation are your control system. And so that allows operators to have a very dynamic and pretty realistic experience running the facility, kind of depending on how in depth you choose to go with your simulation. It can be as simple as just making it so that your graphics look right, or very, very, very complex so that you can run all kinds of niche scenarios so that the operators can actually ask, what if something happened, and find out in a safe way.
So I guess thinking about another application of that, one of the challenges I guess we see from a control perspective is like in the pharmaceutical industry where they're changing materials very quickly. They don't have time to do a lot of programming and stuff like that. I presume simulation could be a very good tool to help them do those transitions and get up to speed very quickly.
It can. It's still an engineering tool, so at some point it's kind of balancing like how far do we go, right? The more effort you put into making your simulation accurate, right? People like to throw around the term digital twin in this space as much as any. And how much of a twin is it, right? Is it really, really accurate, which is great for certain things, or is it kind of quick and dirty? And for the pharmaceutical industry, despite being very clean in reality, quick and dirty actually does pretty well for them because they're looking for more like, how do I water batch this without building the facility, right? How can I walk through my batch from top to bottom, go through every hold condition, really understand like, what is my sequence going to look like? Does it work how I thought it was going to? And you don't need complex logic to figure that out. You don't need to know um, how the, if you've got bugs, if it's a bioreactor, it's like, I don't really need to know how that's producing, right? I've already done my experiments in the lab. I feel pretty confident in that. But I do need to know, like, am I going to trip my hold condition because my interlock and my sequence do not
Hmm.
work together? So
So would it be
it
fair to
allows for
say?
some of that qualification. Yeah.
Would it be fair to say it's in the batch world, it's just as effective? I mean, batches are somewhat different to continuous, but the models, I guess, is it more complex? I'm not sure.
It it depends. So when I think about process simulation, like I mentioned earlier, there's always a control system on the other side, right? So we're gonna build out like a P&ID version, or we'll say for now a P&ID version of your facility, right? Where we've got vessels and valves and pumps, and we're simulating all of that. We also have to simulate the wires and the actual controls. So the emulated control system sometimes dictates whether or not batch is easier or more challenging.
Okay.
Because the one of the features that people tend to like in simulation is the idea of like taking a snapshot,
Hmm.
right? Continuous is a big deal because like if I'm running a refinery, it might take me a day to get up to steady state because it's so complex and it takes so long. So I want to take a snapshot at steady state, and then I can run my training at that point, and I feel great about that. Some software platforms use sort of like a separate batch executive to run the high level logic,
Hmm.
and it's going to depend on your control system and your batch executive whether the snapshots work well. So if your logic is simple and your batch executive and everybody gets along really well and you can restore snapshots and you can get to that point in your batch that you care about, everything's great. But and from a process simulation perspective, it's usually pretty good. But it's that question of like, do your controls really allow you to go to the point that you want to and actually restore your batch to the point that you want to train at?
So you could almost modularize it and say, okay, well, the heating is going to be the same for every, or the model at least is going to be
Yeah.
the same for that equipment,
Mm-hmm.
and maybe for families of equipment. The reaction stage
Oh
may be a
yeah.
little different, so you could actually get a lot of efficiencies that way.
Yeah, you definitely can. And also like, so my expertise, my training and what I've spent the most time in is Emerson's Mimic product,
Hmm.
as an example. And they've got two different kind of philosophies on how to model. One is function blocks, which is going to look a lot like if you're familiar with like a HYSIS, where it's going to be a vessel connected to a valve, connected to a pump. And it's going to do all of the calculations for you. There's also the philosophy that you could use mathematical blocks to do things. So you could have an integrator and you could just say, like, my level goes up or my level goes down.
Hmm.
Not particularly concerned about the curvature of the vessel. My temperature goes up, my temperature goes down. Not particularly concerned about the heat capacities of my liquids. It's fine. And depending on which philosophy you take, like I used to do this all the time when I was in automation engineering, because from a testing perspective or from a very simple training perspective, you just need that kind of directional,
Hmm.
like, is it going where I want it to? And you can bulk generate that kind of stuff, right? You can say, I know my level model is always going to look like this, and I just need to know what does my flow path look like.
Hmm.
And you can really easily build that fairly quickly. It just takes that sort of like philosophy. And that's going to be a lot faster than building out an entire, you know, building your P&IDs, but in another platform again.
Okay. So I guess I hear a lot of terminology in the simulation world that maybe for the layman is a
Yeah.
little esoteric, perhaps is the word.
Mm-hmm.
But what you're describing sounds like maybe sort of a middle fidelity, if that's the right word. The low end
Yeah.
stuff, I mean, I'm not quite sure how we would use like a low fidelity type model, and then obviously the really high
Mm-hmm.
fidelity stuff, which I guess is more on the process simulation type side. Would that be fair?
Yeah. And fidelity is one of those words, like, to me, it's a little bit of a dirty word just because everybody has their own opinion of what is low, medium, and high fidelity. It's really like a spectrum because for a lot of the products that not every product can go simple enough. right? If you're looking at some of these really, really in-depth process models, they require so much engineering information. They're either accurate or they don't work,
Mm-hmm.
right? Those are kind of the two options. But there are models, NIMIC is one, where you can have this kind of flexibility and fidelity. And it really just comes down to like how much engineering are you putting in.
Right.
For the for what I was talking about with like the mathematical blocks, we just have integrators, maybe we're doing some conditional stuff. That I would say is low fidelity, maybe like somewhere between low and medium fidelity, because you're doing more than just starting the pump, but at the same time, you're not really modeling the process.
Mm-hmm.
And then to me, where I kind of draw the line for medium fidelity is that you're starting to get into like, are you doing like a full material balance? Are you starting to do a heat balance and kind of defining it based on what principles are you really following,
Mm-hmm.
right? For these kinds of things, we take, at least the way that there are other modeling methodologies, but the one I'm most familiar with is first principles. So we're actually doing the math, right? Like you would in school, to figure out like, okay, what is my temperature? How is my column performing? All of that. That's what the software is doing.
Mm-hmm.
And to do all those engineering calculations, basically, which ones are you doing? And the more calculations you have to do to answer your questions, right? Or the more that you're just doing in general, uh, the higher fidelity you can consider that to be. So if you need to know the reaction, you're kind of pushing yourself that way. But if you're running a corn elevator, you probably don't need to do that many calculations
Mm-hmm.
for that.
So if I had a greenfield facility, and I was thinking, okay, I'd
Mm-hmm.
like to use simulation throughout the process. So I guess different phases to that, right? Obviously, there's the process design, which may or may not use simulation. But then you get
Mm-hmm.
to startup and you want to test things beforehand. So I guess, maybe a low fidelity sort of model where you can open and close valves sort of thing, and then build on that to get into more of the training systems where you want people to interact with the system. Would that be sort of an approach you could take to sort of build up the fidelity, if you like, over time to support your activities as
Yeah.
you go through?
Yeah. And that is what I generally recommend as an approach. So there's sometimes this want to eat the elephant in one bite,
Hmm.
right? You want the high fidelity model eventually. I have capital funding right now. I kind of want to I kind of want to fit that into my budget so that I can get the high fidelity model. The challenge with that is that if you're testing against a high fidelity model, that's like trying to run a control system on a plant that is not built yet, because you're unless there are exceptions. So like oil and gas, sometimes it's literally a copy of whatever other facility, and so we have a lot of performance data and we have enough data to actually build a successful model.
Hmm.
Great. For a lot of facilities, we're making tweaks. It's not exactly like some other facility, and so trying to build a high fidelity dynamic model from non-existent facility means that, again, like your controls which aren't tested are trying to be run against a facility that is not tested. So where's the problem?
Hmm.
And that becomes a big challenge to try to whose fault is it? And so it's much easier, as you said, to kind of start with okay, let's maybe more than just starting the pump, opening the valve simulation. Let's have enough to say, okay, my sequences work. Maybe I've got a few dynamics that I really care about. I'm going to add a little bit of extra. I'm going to add some of those calculations in. I'm going to make it a little bit more complex so that I feel confident in my control system. Maybe I add a little bit so that we can train on standard operating
Hmm.
procedures for startup. And then you can really identify, what do I really want to train on going forward, and add fidelity in just in certain areas, perhaps, right? You may find that the operators in utilities, they got what they needed from the system that you used for factory acceptance testing of your control system. The operators in distillation might need a little bit more because it's a lot more complicated to run. Or if you work in an area with a lot of SIS, maybe there are safety things that you want to consider.
Hmm.
So by building like that, as you said, it gives you that flexibility to grow.
So I guess thinking about the process of training, um,
Mhm.
very early on, you're going to have to be hiring people. And so have you seen sort of an application where clients are using maybe a low level sort of simulator, but just to identify those people? So using it as sort of part of the selection process to say, yeah, these people can operate a DCS, they understand a little bit about the process, they can open and close valves. It seems that would be sort of a useful competency test, if you like, for new operators.
It does. I cannot say that I have ever seen anybody use it in that way, but to say like if somebody has something on their resume, they say that they have run maybe they've said that they've run a specific control platform,
Mhm.
right? To be able to say I'm familiar with this because you and I both coming from the Emerson world, like Delta V looks like Delta V looks like Delta V most places.
Mhm.
They could basically drop me into most projects and I could pick it up. And so, yeah, I mean, it's an interesting idea to be able to at least show it to someone and say, like, take a few simple actions, right? See if this is something that you're familiar with. Is
Mhm.
this, or even just a competency assessment when you get hired to say, do you know how to run sequences? Do you know when you should and shouldn't? Are you going to be the operator that turns auto off on all the valves?
Yeah.
That would be an interesting application of the simulation product to kind of do that evaluation because it's not really it's really just to say like how much training do you need,
Mhm.
right? And how much do we need to invest versus how much do you already have? You don't have to sit through the basic training if you already have.
So do the training modules have the ability to track like response times and things like that as part of the training simulator to say that the performance was up to scratch or
Mm-hmm.
whatever the benchmarks might be? Is that part of, say, a typical training simulator's features?
I don't know that it's part of the simulators features. So because of how this is set up, right, between the process simulation and the emulated control system,
Uh-huh.
right? I'll always go back to those being the two pieces because they are typically separate things intentionally so that the control system is more or less unchanged from production. It's just a copy. And then your process simulation is as close to or far away from reality
Hmm.
as is needed for the application. So the features that you have available to you include everything that's in your emulated control system. So if you're historizing certain things to try to collect data and understand things about your
Right.
control system, you could theoretically do that
Hmm.
for your process simulation. It's not something that I have seen requested necessarily. A lot of times the kind of stats that people are interested in just because like simulation is another tool that you have to maintain your training program is too.
Hmm.
So if you're building out these really complex scenarios with a lot of data points that you're pulling from, the it is not necessarily baked into the simulation, so it's all custom roles.
Right.
Uh,
Right.
and so that means that it's not currently being captured. There are some pretty cool functionalities that are starting to bubble up as like training standards or starting to be requested in terms of like RFQs and things like being able to backtrack.
Uh-huh.
So a lot of it is instructor led at this point. Instructor sitting down and either starting or participating in training with the operator. And so when an operator makes a mistake, being able to identify it and then actually go back in time. So the snapshots that we talked about earlier, it's actually taking snapshots as you go so that if the operator makes a mistake, we can pause. If I'm the operator and you're the instructor, you can talk to me about the mistakes that I've made,
Hmm.
how I could do it better, and then I can retry in real time without having to go through everything all over again. The other thing that's becoming more common as a feature is like a playback type functionality to be able to either watch the actions happen again or watch a video
Hmm.
of like, well, what did I do wrong? Because it's all kind of coming back to that. Less about analytics at this point, more about operator experience and how do we check the next box
Hmm.
right on our training program.
So it could be used right throughout the training program from selection all the way through to maintaining certification using the same tool, if you like, but just
Mm-hmm.
maybe different scenarios and different things that are built into it for those.
Correct. Yeah, and the scenarios are really great. And they can be really powerful. Again, when you're first getting your training scenario or your training system, you may be focused on like standard operating procedures and that sort of thing, making sure that everybody like meets compliance,
Mm-hmm.
right? I'm certified to run this unit. I have completed this training. At some point, when training programs have been running long enough, we've got all of our operators certified, maybe we have an incident, that's really where this starts being even more powerful. Not only do we want to put the engineering tools in place in the control system to try to prevent things from happening.
Mm-hmm.
Like we talked about last episode, there's all kinds of reasons that stuff goes wrong. And so to be able to have these specific training scenarios based on the unit itself and say, we go down, maybe we do an analytics, maybe we do some analytics on our production and say, we go down the most because of this kind of failure.
Mm-hmm.
And maybe we can't fix it right now.
Right.
So we need the operator to be able to respond to it. So being able to have those specific training scenarios, those failures in place, and have the operator work through them, then you can kind of enhance and continue to help them understand the process and help make sure that the system stays up.
Okay. I guess switching gear a little bit, looking more at the engineering side, and we talked last podcast about alarm management being another one of those issues that hurts us a lot. One of the other things that we've seen is APC. It sounds great technology, but when it stops working, the operators struggle to pick up from the automated systems. And I'm guessing we can use the simulation technology too um, to allow operators to experience those APC turns off, or even alarm floods, or those scenarios would help to, or even tuning the alarms, tuning the APC on a simulator. Again, I'm not sure whether that'll take a higher fidelity to make that work in the case of APC, but I'm sure there's applications there that you've come across.
Yeah. So starting with like state-based, whether it's alarming or control, right? I look forward to the to being able to dig into the topic in general more, but from a simulation perspective, it can be very powerful because from an engineering side, being able to confirm like this is complex logic that you're running in terms of like moving states.
Mm-hmm.
It's not a series of steps. It's kind of a different philosophy to that. So being able to confirm that you executed it correctly, and then to make sure that the operators not only that they know how to interact with it, but that they have the confidence in it.
Mm-hmm.
Right? Earlier, I mentioned the thing that I think we've all kind of bumped into as automation engineers, that auto gets turned off when we don't think that it's doing as well as we would do it. That is certainly the case for state-based control and some of these more complex automated type
Mm-hmm.
systems in certain cases, because there's always a point where you might need to override. So they need to have that option, but how often are we doing it and when are we doing it? So simulation helps build that confidence to say like, okay, I actually understand why it's doing this, why it's maybe doing something that's counterintuitive to what I would have thought,
Mm-hmm.
but that doesn't mean that it's wrong. And then from an alarm management perspective, yeah, being able to experience that. I think that's mainly from like a testing perspective, or being able to get familiar with a platform. Like Emerson's AgileOps is a separate platform with some alarms that come through to the Delta V side. So being able to say like, okay, what does this look like now
Mm-hmm.
versus what did it look like previously? Same with like graphics and stuff. Anytime that there's a change, it's always good to get familiar with it, and that's all very easy. Yeah, advanced process control. This is like, if you're familiar with Greg McMillan, that's kind of his world of, tuning and getting really into the details. He's a big advocate for high fidelity simulation, and that's why. Is because when you get into this kind of optimization space, which is really great, it can save companies a lot of money to be able to tune their systems and get to this really strong point, making sure that the operators understand what's going on well enough to not turn it off.
Mm-hmm.
All of that takes that very high level of simulation, that high fidelity, to give you all the variables that you need for that advanced process.
And I think you made a point that you didn't necessarily call it out, but supporting management of change, being able to test things before they get implemented. As you mentioned, sort of maybe changing the control scheme or whatever. Having the operators have the ability to go and sit at a system and see what maybe the graphic changes are, maybe see what the control logic does, maybe the sequences. Great application,
Hmm.
offline application, and not having to interrupt the process to do that.
Yeah. And not only that, but also to change their procedures before they actually perform them,
Hmm.
perhaps. So making sure that, and this is one of the biggest challenges of simulation is that if you're not making your change in the simulation first, which is a great thing to do, by the way, because you get the value of all the testing and everything. But if you don't do that, then maintaining the simulation seems like a big old pain in the neck because now I have two systems to maintain as opposed to one beautiful system to test on
Hmm.
and then push to production. And so the by incorporating it into your management of change and recognizing the value that it has to your operations team to do that initial training, to get their operating procedures up to date, to identify safety needs and potential points of failure right during startup, then if you're able to adjust your workflow and your management of change to support that, then you can get a lot of value out of it.
Hmm.
Um, in terms of that goes above and beyond just the testing. When I say just the testing, like the testing is really important too. but there are more stakeholders then, and that it's easier sometimes to get the time to work on these things, right? Because a lot of times when I see simulations that don't stand the test of time, it's very often because there isn't time or there isn't budget to maintain or to make those kinds of workflow changes
Hmm.
to maintain them. And once they're in place, it's just your regular everyday life and it's no big deal, but change is hard. So,
So, I mean, I guess years ago, it was very expensive to maintain the systems. What I hear from vendors today is that, well, we're all cloud-based, we can support it remotely, all these things. Do you think that's made a
mm-hmm.
real big difference in making the maintainability of the systems more easy or accessible, or is it really more of a salesy sort of approach to, yes, we can do better now because we have more technology?
I'll let the salespeople speak to the licensing and whether or not that's easier to maintain.
Hmm.
From the from the actual keeping your simulation up to date, I think the biggest things are going to be like actual features in the software.
Hmm.
So there are today, and there's a focus on how do we make that easier. Things like automatic flow tuning and being able to do some of the actual engineering automatically helps. In my experience, though, like if you do even a medium fidelity model of your entire facility, that's that's still an entire facility to maintain.
Hmm.
Like it's any change that you make still needs to happen in the simulation. And as much as I think that it has a lot of great applications, you need to know who is like the biggest challenges are who is owning it. Do they have time to own it? And do you need it?
Hmm.
Um, I I think about simulation very broadly. So everything from maybe you have like OPC watch it or some, variable where you can just force individual values. That's simulation.
Hmm.
It's you. You're the simulator. How much you trust yourself comes into play. But that's simulation. All the way up to the very, very, very advanced. Maybe it's even connected to your production simulation. And so when you're doing these things, it's always important to allow yourself to ask the question, where do I draw the line?
Right.
Because whatever level of fidelity, whatever platform you pick, you're still maintaining a virtual plant,
Hmm.
whether you like it or not. So that comes with more effort. And there are consulting firms that will help you do that. PlantWise will help you do that. We would rather you incorporate it into your workflow and that have you own it yourself, right? And we're happy to help you understand what does that look like and how do we get the skills to do that. But there are a lot of ways to do that through contracting, through um, owning it yourself, but just making sure that when you adopt this kind of technology, you know what that looks like. Because to your original question, do I think it is that much easier? I don't know that I do.
Okay.
It's still a virtual plant,
Hmm.
and there is effort that goes into that. So scoping it correctly is really important.
So when people talk about digital twin, that sounds like a scary proposition.
Yeah.
Maintaining a complete replica of your facility. Maybe easy to configure, but to maintain, to your point, might be extremely burdensome.
And it depends on your industry, right?
Hmm.
We go back to like what we were talking about earlier with life sciences. They change all the time.
Hmm.
Should they have a really complicated version of that? Probably not. But do they maybe want some modular models of different unit operations and then they can kind of change some of the connections between their example skids and kind of make sure that everything's going to play right? That seems reasonable. Or maybe they just want it to be able to be, we call it tiebacks, right? Where it's just the pump turns on, the valve opens.
Hmm.
That you can work your way through a sequence. It's not as good, right? Again, you kind of have to trust yourself on that. But if you're changing constantly, you're maintaining a whole plant. That is up to you whether you think you have time to maintain
Right.
a another one. But it's yeah, it's all a balance. I think that's the case with a lot of these digital transformation tools is that they are transformational
Hmm.
and that takes effort. And I think that it can sometimes be difficult to justify the cost and the time with that. So it's about kind of picking your battles and making sure that you're spending the time where it matters
Hmm.
and in the amount that it matters. Because if I could have a perfect model of, or if I could build and deliver and successfully have my customers adopt high fidelity models of their facility, absolutely, that would be great. We all be able to do optimization projects. It would be so cool. That's just not the best fit for everyone.
So consider the total cost of ownership, is what you're saying, not just the
Yeah.
initial configuration. That may be a small part of the total cost.
Yeah. And with simulation especially, like unless you've got somebody in house who's going to own it and do it as part of their workflow, that's service hours, right?
Hmm.
It's not just the software licensing.
Yeah. And one of the biggest questions we often get posed is when we're doing control room designs. Where should the simulator go? Traditionally, it's gone in the training center up at the front admin offices, and the operators may see
Hmm.
it once. They may get to run it. But some of those things we talked about, like MOC support, training, to
Hmm.
our minds, it should be right next to the controller. So the operators can very easily. Would you agree with that sort of approach? That it needs to be accessible, it needs to be easy to run, it needs to duplicate the environment that they're in, all those sorts of things.
Yeah, I think to that point, it really does need to be a part of the operator's environment if you want them to use it for this kind of training system. And the question I think, or the concern that people have is that it looks just like reality. And if it's right next to reality, how do we know for sure, right, that we're in the right space? But
Hmm.
it's going to be a physical, at least a physical separation between training or change and production. But I think that that is a hurdle that it's probably kind of legacy, right? Because
Hmm.
we live in a world now where like I'm logged into Microsoft Teams as two different users right now, right? And I that's something that I'm aware of and engaging with. And you don't want to do that with your production system, right? You still want that physical separation, but that is more separation than most of these operators that are coming in, these millennials, Gen Z operators are used to even having.
Hmm.
Right? They're used to having multiple tabs open and being in different environments constantly. So I think that the fear that somebody is going to mistake MOC for production or vice versa is probably lower than we thought it was years ago, which would indicate why training maybe was further away. But at the same time, like I think people are still going to be hesitant to it,
Yeah.
I suppose. There's a lot of those kinds of just it's been this way, so it is this way kind of things.
I don't think I would propose to have it on the console, but
No.
like maybe having a room that could see onto the control room so they can go in there, but still see their large screen display, still be part of the process. And if they have to break away, they can go back into the control room. So, but yeah, it
Well,
scares me having it on the
yeah.
console.
Yeah, it would scare me too. And but you would be surprised. I mean, I've had customers ask if they can put more than you would expect. Ask if they can put their simulation system on their production servers, and we're just like,
Wow.
we really don't recommend it
Hmm.
for a lot of reasons, right? But it's but yeah, if there's a physical separation, yeah. Other than that, like if you had a laptop,
Hmm.
right, which is clearly separate from your production system, to be able to let your operators kind of interact with it and touch it, the more that they're, it's like anything else. The more that somebody's engaging with it more as part of their workflow. If they're going to do something they're not comfortable with, right? It may not necessarily be a shutdown. Maybe they just have to do a procedure they're not as familiar with. Being able to go run it real quick on the training system, the shift before they have to do that, because some of these things are planned. That's going to make them feel more confident. They're going to perform better, and they're going to know how to handle that situation a lot better.
Mm-hmm. So I guess thinking towards the future, if we had a crystal ball, augmented reality is another, I guess, is a type of simulation. If you can walk through the process, you can walk through things ahead of time. That's the sort of simulation that people are saying, well, we're going to have operators have these headsets on and be able to walk through the plant and see all this information. I guess that's one sort of future view, but do you have any other thoughts of what might be in the future for simulation, the different uses, different technologies that we may be able to use to I guess, integrate it with the control environment?
So I think that there's opportunities to enhance or maybe streamline some of the fidelity stuff that we talked about, right? That's all coming back to engineering. Theoretically, with the right amount of data contextualized in the right way, and using some of these data digesting type tools, right? Like you could theoretically more efficiently come up with the constants and the rules, right? That guide your simulations to some extent. So it could help slim down the engineering time to get your model configured. As far as like, I think AR has a really great application in like reliability, to be able to like walk around and maybe in your Google Glass see, your pump and information about your pump or something like that, or for the operator. And then for like VR, there are training applications today where you can walk around your facility and have your maintenance person or your field operator interact with your board operator. It's interesting that if we were to work through the engineering challenges with that, because again, these are just more plants that you have to maintain today. But there are other physical kind of challenges with that too, right? Like, does each operator get their own glasses? Are they prescription? Do they need to be sanitized? And I was in actually an AR VR subgroup of the Bioforum, and that was what they were most concerned about. And so, interestingly, I don't really think that it's the software technology that's going to slow or halt some of those things from being adopted. I think it's the practicality of it and the physical, and so and so wears contacts, so and so wears glasses. How do I clean this post COVID, right? Like, I don't know that I want to share these glasses with somebody. That's something that's that close to my face.
Yeah.
And so I think that the tools will get easier and faster in terms of the simulation. I think what I would like to see is a bridge between what we talked about at the very beginning, the steady state, right, and what you used in design, and where you end up in dynamics, because there's still a pretty good gap there. Even if you have a tool that can go from one to the other, there's still a lot of engineering that goes between the two. So making that and that kind of digital thread through the design, execution, lifecycle process stronger and less painful. I think that would be where I would like to see the technology improve.
So I mean, thinking about like APC with self-learning systems, where you let it do bump test itself and you let it learn the constants and all those things. Probably a long stretch, but a self-learning simulator, plug it into historical data and let it build itself.
Perhaps. Yeah. Or even like one that I like that I've heard bounced around a little bit is the same but for training. Right? We see incidents, what incidents are coming up, and automatically generating your training scenarios based on challenges that operators have. Right? That's learning all of the variables, because like process simulator has more information than we're actually pulling into the control system. So that's one of the reasons that it's a little bit challenging, right? Like I know the size of my vessel and I know the level, but like maybe I don't have a temperature sensor on every vessel. Maybe I don't have a pressure sensor on every vessel, right? So like sometimes you don't have enough information to do that kind of learning. if somebody wants to deck out their facility in all of the possible sensors, they've got pH on everything and everything. That would be very cool. That'd be a very cool research project for probably a university to do first. But I think doing something like, yeah, learning from what incidents were caused, what is the root cause, and then automatically generating those training scenarios, I think that's in the seeable future. Less fuzzy crystal ball.
I think we covered a lot of ground. I
Yeah.
appreciate a lot of your insights because, like I say, it's not really my area of expertise. But I think, sort of summarizing, there's a lot of applications all the way through the life cycle of, onboarding people right the way through to certification, but also crossing over into engineering support, management of
Mm-hmm.
change, lots of different applications, but different types and different configurations of models that support each of those. So you need to be thoughtful on how you apply the technology. I think is perhaps the message that I've taken from a lot of your comments.
Yeah, I would generally agree. Yeah, it's such a powerful and flexible tool, right? It is a paper and pencil, and you have to decide what you're going to draw it successfully. And so having those kinds of conversations with people that are really familiar with the technology can be very helpful, or just doing the research yourself to figure out like, okay, what do I actually want and need? Because I've seen high fidelity sold to people who didn't need it, and it's
Mhm.
not really the best case for anybody. And hopefully the conversation wasn't too jargony. But yeah, no, I'd be interested to see what our audience thoughts are, and if there's any questions or clarifications, we can circle back to this at some point. I'm sure, like this is my bread and butter, so I'm sure it's going to come up in other conversations as well, just because it's such a big part of testing and training. So.
I think maybe in the future, we can look at. Hopefully, we'll get some feedback on these podcasts. You'll get some questions,
Hmm.
and I know the old shows used to have a mailbag, right? It would start the show off, and we had a letter from Mr. X who talked about this. So we should think about incorporating feedback in maybe in the podcasts and getting some
Yeah, that'd be
answers
great.
back. So
I'll make us a mailbag if we get enough comments. That way we have
virtual
this.
mailbag.
Thanks so much for joining us today on the Operational Edge. We'll see you next time.